Hey, what's up, guys? First of all, I hope you guys are doing extremely well. So, guys, we will be starting a new series where I'm going to be trying to solve code forces and lead code problems. And this is going to be the first episode of the series. So, I think this will be a good series in order to track my progress as I get better at solving. So, today's problem is this one. It's 1805A, we need the 0. And the topics are bit masks and brute force. As you can see, the problem is 800 rated. So let's start. There is an array A consisting of non-negative integers, okay? You can choose an integer x and denote B of I equals A of A XOR x. Okay, for all 1 less than equal to I less than equal to n, where XOR denotes the bitwise XOR operation. Is it possible to choose such a number x? Okay, so that's the value of the expression b1, b2, b of I equals a of I, b2, bn equals to x. It can be shown that if a valid number x exists, then there also exists x such that x is greater than equal to 0 and less than 2 to the power of 8. Okay. Each input contains the first line is t, then we have n, then we have the array, and it is guaranteed that the sum of n over all test cases does not exceed 10 to the third. Okay, so first so we have t, we have n for each, and we have, okay, let's get t, cnt, while and n, while t minus minus, we're gonna cnn. We're gonna create a vector array of size n. Okay, all right, let's see the examples. So 1 2 5, does there exist a number x which by adding 1 to 5, this is 8? In the first test case, after applying the operation with the number 6, the array becomes 7 4 3 7 4 3 7 4 3. There are other answers in the third test case, such as the number 0. Third test case. Also, basically, I think that, okay, let's see out. I think that this is gonna be uh basically what 6, which is 110, XOR with 1, which is 001. So this is gonna be XOR with this. So 0 and 1, that is 1, 1 and 0, that is 0, and 1 and 1, that is, so that's how we get 7. So here I'm guessing x is gonna be equal to 6. Okay, then there also exists x such it can be shown that given a valid number x exists, then there also exists x. Okay, there's an array inconsistent. You can choose an integer x to denote that. Is it possible to choose such a number that the value of the expression b of 1, b of 2 equals 0? Okay, so let's check. So we have b of, so we have 111, and then 4 is 100. Yeah, this is 1, this is 2, this is 4. So right now we have 1 and 0, that's 1, 1 and 0, that's 1, and then this is 0, so this is 3, and then we have 3, Then we have 3, so we have 0, 0, 1, 1, and 0, 1, 1. So this is 1 and 1, 0, 1 and 1, 0, and 0 and 0, 0. Okay. All right. So I think that is what we do now. We just need to run a loop. We need to run a loop from 0 to 2 to the 8th. Okay, and if we find a number that after XORing all the numbers, um, wait. So we need to XOR first all of the numbers with, so this is 1, um, this is 6. So this is first L I equals 0. Okay, so all right, I think I have the idea. Let us see in for int I get 0, I less than r, I less than n, I plus plus. Let's see in n. Now we're going to have for int x equals 0, x less than pow of 2 to the 8th, x plus plus. Okay, so now we're going to have a vector int r2 of n r2. Okay, so 2 of n, we're going to say um should that exists or -1 otherwise. Okay, so okay, print an integer x if it exists or -1 otherwise. All right, so we need to XOR this with this with this, x with 1, x with 2, x with this, and we need to store it in a new array. We need to store it in a new array, x such that. Okay, so uh for for int I get 0, I less than n, I plus plus, array of 2 dot push back x XOR array of I, like this. Okay, okay, so I think this is gonna be like this, maybe, and now we're going to say int res equals 0. Okay, and we're going to say for int I get 0, I less than n, I plus plus, res XOR equals array of I, actually array of 2 of I, array of 2 of I. Okay, so and now if I'm gonna say bool flag equals false, so we're gonna say if res is equal to 0, we're going to say flag is equal to true. Okay, and we're gonna break, else we're gonna continue, and if not, if flag, we're gonna see out x. So let's say int x is equal to 0 initially. Okay, and then okay, and then gonna see out x with an end line. Else we're going to see out -1 like this. Okay, and that should be it, I think. Let's test it. Let's test it. So 5, 3, 1, 2, 5. Oops, I misdid that. So let's do again. 5. Okay, again. 5, 3. That's 1, 2, and 5. 1, 2, 5. We get 0. Hmm. We get 0. Okay. Okay, let's stop this and let's try to debug this. So, uh, for so I'm gonna see out array of 2. We're gonna for auto n in array of 2. We're gonna see out n with a space. Let's see out n line. Okay. So that is gonna be 1, 3, and 1, 2, 5. Array of 2 is 0. Oh, okay, so this loop does not run less than n I plus plus. Do that push back r of I. Okay, do we get r of I? Do we get r of this? One, 1, 3, 1, 2, 5. No, we do not get the input. Why is that? There int. Why do we not get the input? Huh. Why? Array of n. Do we get n? Do we get n or not? Do we get n or not? Okay, we get n. Now 1, 2, 5. Then this doesn't happen. Oh, okay. It has to be array of I. Okay, guys. Okay. Okay, now let's see what happens now. Let's see what happens now. So 1, 3, 1, 2, 5, 6. Okay. Okay, let's try all the test cases now. So 5, 3, 1, 2, 5. Okay, we get 6. Next is 3. Uh, 1, 2, 3. Okay, we do get 0. Next up, 4. 0, 1, 2, 3. 4, 0, 1, 2, 3. We get 0, but we should get 3. We get 0, but we should get 3. Okay, and next one is 4, 1, 2, 2, 3. Oops, misspelled. Misdid that. Okay, let's try the final 2, which is, let's see, 2. Okay, stop, run, 2, 1, 2, 2, 1, 2, 2. No, 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 no. First 4, then 1, 2, 2, 3. Okay, we do get -1, and the final one is 1 and 1. Okay, and we get 1. So the only test case which does not work is when this one is 0. So let's just run that again. So we get here 1, and then 4, and then 0, 1, 2, 3. This gives us 0, and it should give us 3. Let's see what's the problem here. Okay, let's see what the problem is. Okay, we have this. Okay, I think I may see the problem. Um, see out inside res, yes. Okay, we're gonna see out. We're gonna see out. Let's see out X as well. See out X as well, and then see out res. Res. Okay. And let's see for no. So 1 4 0 1 2 3. Oops. 2 3. Okay, so X is 0. 0 1 2 3. Res 0. Yes, inside is okay. This is the problem. So what do you want to say? Is it possible to choose such a number that the value equals 0? It can be shown that for each test case printed integer, if it exists, if consisting, you can choose an integer x to denote this, where this denotes bitwise XOR operator. Is it possible to choose such a number x that the value of expression equals 0? It can be shown that a variable number x exists, then there also exists such that each test case contains multiple test cases. The first line contains, okay, so I'm guessing maybe you want the largest number, right? or something, I don't know. Okay, so XOR operation. Okay, let's say x is equal to x is equal to 3, then 0, 0, and 3, 0, and XOR 3 is gonna give 3. Then we have 1 XOR 3, which is 0, 0, 0, 1, XOR 0, 1, 1. So this is gonna be this is gonna be 2 equal to 2. So we have 3 and 2. Then we're gonna have 2 XOR 3. So this is gonna be 0, 0, 1, 0, and then 0, 1, 1. This is gonna be equal to, this is gonna be 1. No, this is gonna be 1, yes. And finally we have 3 XOR 3, which is 0. Okay, so now we have 3, 2, 1, and 0. Okay, 3, 2, 1, and 0. So we're gonna have 3, which is 0 and 1. Then we're gonna have 2, which is 0 and 0. 3, 2, 1. So then we're gonna have 0, 0, 1, and finally we're gonna have 0, 0, 0. Okay, and then uh this is 1, this is 1. So first we're gonna have 0. Maybe we're gonna have 0 first, then we're gonna have, so even number 1, even number, so even number is 0, odd number is 1. So this is gonna be 0, then it's gonna be 0, and then it's gonna be 0. Okay, but also this works with 0, it seems. So it's an integer x equals to choose such a number that the value of this expression equals 0. It can be shown that a valid number x exists. It can be shown that if a valid number x exists, there also exists x such that this is true. Okay, how about if x equals 0? So first it's gonna be 0, 0 XOR 0, which is gonna be 0. Then it's gonna be 0 XOR 1, which is 0. Then it's gonna be 0 XOR 1. No, this is 1, 0 XOR 2, which is going to be 2, and then 0 XOR 3, which is going to be 3. Okay, I think I'm gonna make a vector called int x's like this, and then I'm gonna first equals 0, we're gonna say x's not push back x like this. And then we're gonna get if x's dot x's, is this how I wrote it? x's dot size cout. We're gonna get the max element in x's dot begin, x's dot end. Okay, else we're gonna see out -1. So let's see if this works now. 0 1 2 3. Okay, what the heck? Okay, what happened? Okay, push back is equals 0 if what is going on? Okay, what happened now? Um, hmm. Okay, something is wrong, but I do not know what right now. Okay, so first array 2 is 1 2 3. x1, x3. It's equal to 0 every time for some reason. For some reason. Okay, no. Okay, I think I found my mistake. It is not that we need max x. It is not that we need max x's. It is that we start res from 0. It is that we start res from 0. And res actually needs to start from since the array is going to have at least one element, it's going to have to start from array 2 of 0, I think. Okay. Okay, so we're gonna remove this. I'll comment out this. Comment out this. Comment out this. Okay. And now let's see. Let's see. Okay, and we're not gonna start from 0, we're gonna start from 1. Okay. Now let's see. So 1 4 0 1 2 3, we get 0. We get 0. Hmm. Okay. Does it work for other cases? 1 3 1 to 5. Okay, we do get 6. We do get 6. So why does it not work for, let's say, n x does not equal 0? Okay, let's see. 1 4 0 1 2 3. We get to 1 now. What the heck? Okay, let's try to figure this out. Let's try. So there is an array consisting of non-negative. You can choose an integer x and denote b of I is equal to a of I xor x for all. Okay, so I needs to be 1. Okay, so where this denotes the bitwise XOR operation. Is it possible to choose such a number that the value of this expression equals 0? It can be shown that a valid number exists, then there also exists x such that this. The first line contains this, then this. This contains in integers. Consider the sum of. Okay. Okay, so first case 6 is that. Second case is 0. X is 0. Then the third case. There are other answers in the third case, such as the number 0. Oh, okay, so there are other answers in the third case, such as the number 0. So that means it works, right? That means it works. So in the third, okay, so this is the third case. 1, 2, 3. Okay, guys, so basically, always read the whole text. There are other answers in the third case. Okay, so basically, I think we have the answer, guys. I think we have the answer, guys. Okay, now let's see where we are. Counting x. Where? Okay, here. Let's comment. Let's stop this. Let's comment this out. Let's see. Finally, do we get the answer? We're gonna get 5. Okay, stop. Run. 5. Then 3. 1 to 5. Okay, we get 6. Then 3. 1 2 3. We should get 0. Then 4. 4. 0 1 2 3. We get 0. As it says here, there are other answers in the third case, such as the number 0. Then it's the fourth case, so 4 4 1 2 2 3. We get -1, and then it's 1 and 1 and 1, and we get 1. Okay, guys. Okay, now let's try to submit this. Let's try to submit this. Let's go submit code. And we need the 0. Let's see. Let's see. Let's see. Let's see. Let's see. Yes, guys, nice. Okay, we solved it. So basically, I solved it like basically, guys, I solved it like 20 minutes ago, but I just did not read the fine print right here that says the third case is equal to zero. No, the number zero is also a possible answer, and that is why we wasted so long on that, but finally I figured it out finally. So thank you guys so much for watching this video. This is the first episode in the solving series. Make sure that you like and subscribe with notifications on so you don't miss the future episodes. Also comment and share, and thank you guys so much for watching, and I will see you in the next one. Bye bye, take care.